Hey everyone, in this video we're going to be going over the correct ways to be naming cyclic carbon rings that abide by the IUPAC rules. So before we begin, I have the same consider points as the previous video. What's the longest chain slash ring? What are the substituents? Do we have the correct carbon numbering? Then are the prefixes and suffixes that we need there? And then do we have our name in alphabetical order? So let's begin starting a few examples. Okay, so we have our first example here. Pardon the bad scaling of the drawing, but let's go ahead and name this one. I'll give you guys a minute. Alright, so we're dealing with some sort of cyclic molecule here, and the first thing we should do is try to figure out what the longest chain is. Well, just like we do for a branched alkane question, we just start numbering. So maybe call that one our 1 carbon, and this is our 2 carbon. That's our 3rd carbon. This is our 4th carbon, 5 and 6 all the way up, back to 1. And so it looks like there's nothing else really going on in this molecule, so we're simply just going to call this parent chain, this parent chain is actually going to be the name of the molecule. But since it's cyclic, we need to add the prefix cyclohexane. Hexane because there are 6 carbons. Okay, so that's a pretty basic one. Let's do another one, kind of a derivative of cyclohexane. Let's do it over there. And let's draw our same kind of starting like that. And then let's give something like that out to the side. So go ahead and try to name this one. Well, we begin by trying to find our longest chain, or ring. And in this particular case, we see that we have something sticking out here. So we can call this part, that's a bad bracket, but the part to the, actually let me just close the bracket. So the part in brackets is going to be a chain, and the part not in brackets is our ring. So that's how we're going to separate these two, I guess, carbon pieces. So let's name the one in brackets, call that one our carbon 1, 2, and 3. And we know that the ring is a 6 carbon ring because that's the same as the one that was over there. So we see that 6 is greater than 3, so we have our cyclohexane is our parent, and then we have something sticking out of it, and that's something that's sticking out I'm going to do in white. That something that's sticking out has 3 carbons, and we refer to 3 carbon rings as propanes. And so we can go ahead and name this molecule as 1 propyl, and then our parent, which is just cyclohexane. So why did I pick 1? Well, there's only one substituted part on this parent ring, and so it's intuitive that the only place that would make this the lowest sum would be on the 1 position. Alternatively, you could simply call this just propyl cyclohexane. You don't necessarily need that one. In fact, a lot of the times you'll see it's omitted. So let's do another one. So derivative of this one, we'll see something like this. So that's our little ring. And we have that chain that's sticking off. And let's put something down like that. So I'll give you guys a second to try to name this one. Well, our longest chain looks again to be the 6 carbon cyclohexane. So we have our cyclohexane, and then we need to identify whatever is substituted on this chain. So following the red line, we see we have again this kind of propyl. So we have our propyl, and then following this line, we have, why don't I do it in blue? Following that line, we have our methyl. And so now we can name this molecule. Let's do it in white. We have our first group is going to be our methyl, so let's go ahead and call this carbon 1. And then our second, third, and we don't care about the rest because there's nothing substituted onto them. So we're going to call it 1-methyl 3-propyl. And then I'm going to do this underneath cyclohexane. And so you might be wondering, why did I pick the methyl to be the 1 carbon? Well, when you have two substituted groups that are fighting for the 1 position, you give the priority to the one that is has the alphabetic, I guess, comes out first alphabetically. So M comes before P, and so we're going to let our methyl group have the 1 carbon. So let's do another derivative of the same molecule. Running out of room right here. So something like that. And then keep our methyl group and this group out here. So why don't you guys try to name this one? Well, beginning the same as we have for the last 3, let's notice that our longest chain is the 6 carbon ring, and then our groups that we are concerned about, we see we have an ethyl group that goes along this way, and ethyl, and then we have again our propyl group, and lastly we have our methyl groups. And so that's just identifying our substituted groups. Now we need to number them. So taking note to what I said on the last problem, we want to go ahead and name our ethyl substituted carbon our first, and then we're going to go down and until we get to the 3rd carbon being our methyl substituted carbon, and then go all the way up and complete the chain. And we did this just because we have conflicting substituted groups that are fighting for the lowest or the best priority, I guess, for carbon numbering, and we gave priority to the substituted groups that come alphabetically. So let's go ahead and name this now. So again, following alphabetical order, we have 1-ethyl, then we have our 3-methyl, put our hyphen right there, and then underneath it 5-propyl, that's not how you spell it, cyclohexane. And I've just about run out of page. So this is the correct way to name this particular problem. So let's go on to another set of problems. Alright, so here we have a problem that looks like it has 2 chains attached to it. So considering that first point I had on the very first page, we want to find our longest chain or ring. Well, we have 2 rings, so we're going to defer to the ring that is the longest, and that would be this 5 carbon, get the right color, this 5 carbon ring right here. And so I'm going to put right here that our parent chain is cyclopentane. And then our subchain, so our substituent is going to be this 4 carbon cyclohexane. cyclo, and 4 carbons means butane. And I don't have it here, but the suffix, well, you'll see. So this is all we need to know in order to name this. We don't need to necessarily number this because we know it's implied that since we only have one substituted group, it will be on the 1 position. So let's put our 1, and then our cyclo, and then this is the part I was referring to. We're going to change the suffix to cyclobutyl, so the YL part. And then we're going to finish it with our parent chain, which is cyclopentane. So let's do a derivative of this one, and that'll let's do something like that. That was pretty bad. That's much better. And then let's draw that little chain. Go ahead and try this one. Well, we need to first identify our longest chain or ring. Again, that looks like it's going to be this 5 carbon ring in the middle. So we have our cyclopentane as our parent chain. Now let's go ahead and identify some substituted parts of this parent ring, and we have a methyl group out here. So I'm going to put a dot to represent the methyl group. So let's put a methyl, just write that, so we have that organized. And then again we have our 4 carbon cyclobutane. Alright, so we've gotten this far. Now we need to figure out how we're going to number these substituted groups. So let's consider that our 2 substituted groups start with an M. So start with an M and then start with a B. Well, like in some of the other problems, we're going to go ahead and give priority to the group that comes first alphabetically. And so that's going to make this carbon our 1 carbon. And we have to go around the chain such that we give the next substituent the lowest number. And so if we go this way, this methyl group gets 3, as opposed to if we would have gone the other way, it would have gone a 4. And so I guess I can just go ahead and finish the numbering, even though it doesn't matter. And then we are set to name this molecule. So alphabetically we have 1 cyclobutyl, and then 3 methyl, cyclo, our parent chain, cyclopentane. And that's how you do this one. So let's go ahead and jump into another one. Alright, so let's address this problem. We have kind of looks like a longer chain, and then we have some sort of a more compact, our smallest that we can possibly get of our cyclic rings in organic chemistry. So I'll give you guys a second to try this one. Okay, so we need to identify the longest chain or ring. Well, let's go ahead and start numbering. First, by inspection though, you can notice that this is the smallest possible ring that we can get in organic chemistry, a 3 carbon ring. So this is likely probably not going to be the parent chain, especially when we have a carbon chain. Oh, I'm sorry, this is likely not going to be the parent carbon ring because we have also a carbon chain that is 4 carbons long. So obviously, 4 is greater than 3, and so we're going to defer to this chain, which is our parent chain, and call it butane. So hanging off this butane now is this ring, and there are 3 carbons in this ring. So here's our first, our second, and our third. So it's a ring, so we're going to give it the prefix cyclo, as always, and then followed up by what we call anything with 3 carbons, and that's going to be propane, so cyclopropane. And that's our little substituted group. So that's our substituted group. Okay, so uh, if you noticed, I put numbers on this carbon chain. Well, it's not necessarily the correct numbering that we want to give this particular molecule. So I'll do it in green. It'd make much more sense if we call this our carbon 1, that's our carbon 2, maybe that's our third, and that's our fourth. So disregarding these white numbers, we'd much rather prefer to name this with this carbon being our 1 carbon, that carbon being our 1. So we are all set to name this now. So let's begin by writing our position of our substituting group. So that's a 1, and then our substituted group follows. So cyclopropyl. So we have 1 cyclopropyl, and then our parent chain, which is butane. Alright, so our derivative, we're going to have this same kind of chain. There's our little cyclic part, and we're going to give this now that. And so you can see it's the same thing as above. It's just, flipped maybe upside down, and I changed, or I added 2 little parts to it. So identifying the longest chain, or ring, we have it again to be butane. Now we want to identify our substituents. So this didn't go anywhere, so we still have our cyclopropane. And then we have what looks like 2 more chains, or 2 more substituents right here. And those are 2 methyl groups, so I'm going to write a 2 times methyl. And so now we need to decide how to number this correctly. Well, like we would in most any other problem, we're going to give it the lowest sum. And so our lowest sum is going to be when we make this our carbon 1, that's our 2, 3, and 4. So now we're set to name this. Alphabetically, we have our 2 methyl groups first. So we're going to write 3, 3, then di, meaning 2, methyl, and then 1, our cyclopropyl group, and then our parent chain, which is just butane. And this is how we would name this molecule. So let's do another set of problems. Okay, so here we have a, I guess, seemingly less friendly molecule, but we're going to break it down into pieces and see that it's actually not that hard to name. So I'll give you guys a minute to go ahead and figure this one out. So we're going to begin by, like always, finding our longest chain. Well, you guys can go ahead and check to make sure I'm correct, but our longest chain is going to be this ring, rather, that has the gray dots on it, and that is our cycloheptane. Heptane for 7, cyclo for ring. And now we need to identify anything that's substitute onto this ring. Well, we have, this part that's circled in green, and then we have another part that kind of goes off like this. And right away, we should already recognize this one that I've kind of drawn a red snake underneath. This is just butane. So, right, butane right there. And now our green one, our green substituted group, if you don't remember, we call groups like this isopropyl. And so we have an isopropyl group and we have a butane group. Great, so let's number it. Well, we can realize that whichever way we go, we're going to want to go either that way or that way. We do not, so what color am I going to make this? If I put I'll do baby blue. We do not want to go up at all. So that's bad. We are not going up, because if you can see, if we go up, we're going to end up with 3 carbons in the middle, which is ultimately going to increase our sum. Whereas if we follow the white lines, we'll have 2 carbons in the middle, which is going to give us our lowest possible sum. So which carbon is our beginning primary carbon? Well, following alphabetical order, I would call our first carbon to be the one that has the butane substituted onto it. So this one will be our 1 carbon. It's our 2, 3, 4, and we can go all the way around, but it doesn't matter. So why did I call this our first carbon? Well, B comes before P. Remember, we look at the P in isopropyl whenever alphabetical order is important. So let's go ahead and name this molecule as 1-butane for isopropyl cycloheptane. And that's how we'd name this particular problem. So let's go ahead and do another one. Okay, so here I've drawn our second one for this page. How would we go about naming this one? Well, we need to find our longest chain or ring. And so we see we have a ring that if we go around like this, we'll end up with it being 4 carbons. But notice we have a ring out here where if we go along it, we'll end up with another 4 carbons. And I can go ahead and name this ring butane. And we know this one in the middle is just cyclobutane. So which one do we call our parent chain or ring? Well, remember from the last video that we're going to give our parent chain, our parent chain is going to be the chain or ring that has the most substituted groups onto it. In this particular case, our cyclobutane is, well, it has 4 substituents, whereas the butane, if it were a parent chain, it would only have 1 substituent. So, in naming this, we'd say our parent chain is our cyclobutane. So, there's the right color, cyclobutane. Then our substituents are going to be butane. That should have been in gray, but that's okay. And then we have a methyl group hanging off. Then we also have a propyl group. And then we have an ethyl group. And hopefully it is easy to see where those groups are hanging off of the cyclobutane. So now we just need to name or number this. So I would start by numbering it alphabetically, so call butane the 1. And then we have to decide if we're going to go down or to the right. And I'm going to go down because my pen's having a bad time. I went down because the M in methyl comes before the P in propyl, and so I'm going to give the methyl priority. And then call the ethyl group here our 3, and our 4 is up here at the propyl group. So, in naming this, we have our 1-butyl, 3-ethyl, then our 2-methyl, our 4-propyl, no hyphen, so 4-propyl, and then our parent chain is simply cyclobutane. There. It's a mouthful, but this is the correct answer and how you name it according to the IUPAC rules. So let's go ahead and do one more problem. Okay, so our last problem here, well, we have what looks like a lot of junk hanging around. So I'll give you guys a second to go ahead and try this one, and then I'll try it. So first thing I'm going to do is identify our longest chain or ring. Well, here, by inspection, we can see that our longest ring is the 6-carbon ring, and that is known as cyclo because it's a ring, and then hexane because there are 6 carbons. Okay, so now we need to identify any substituted groups. Well, we have some methane group that's substituted over here, and so I'm going to call this our methyl group that's substituted. Notice also that over here, I'm going to do a diamond. We have some ethyl groups. So at the diamond, we have 2 times and then our ethyl. Well, going up more, we see there's a tert butyl, and so we're going to give this tert butyl a triangle to identify it, and so we have our tert, I'm spelling it out, butyl. And then we have one more group that's over here, and this is our cyclopropane that we've seen before. So cyclopropane. And now we just need to number this correctly such that we have the lowest sum or it follows alphabetical order. So looking at this, I see that there are some substituted groups, or a carbon, a specific carbon that has 2 substituted groups on it. So I probably want to make this my carbon 1, and so I am. And now I need to figure out, well, do I go up to the left or do I go up to the right? Well, I'm going to go ahead and go up to the left because tert butyl alphabetically comes before methyl. So remember, we're looking at the B, as opposed to the M. Okay, so calling that our 2 carbon, there's our 4, 5, 6, just like that. So 1, 2, 3, 4, 5, 6 all the way around. Now we're all set to name this. So we'd give it the name 3 tert butyl 1, 1 diethyl, and then alphabetically what comes next is our methyl, which is on the 5 carbon, so 5 methyl, and then we have our cyclopropane on the 4, so we have cyclopropyl, and then I'm going to do it underneath cyclopropyl, cyclohexane, and that goes right there. And so reading it all out loud, we have 3 tert butyl, 1 diethyl, 5 methyl, 4 cyclopropyl cyclohexane. And that's our correct answer. So this one was a little bit complicated, but we were able to make it easier just by breaking it down, and we followed those consider points on the very first slide that I had.